Hey guys, this is Miss Luris, and today we are going to be starting quote unquote day 4 of our instruction PowerPoint lecture, whatever you want to call it. This is going to be a little bit shorter than the others, but there is a video that I want you to watch, and I will link it to this post. And I definitely need you to watch it before you do the lab that you are going to be doing today. Okay, day 4. Gravity. Now, we all know what gravity is, but technically, most of you probably don't know what causes it. So, gravity is the force that is constantly pulling us down toward the earth. So, let's say I'm holding a book and I let my hands off of it and it drops. Is it going to drop to the ground or is it going to drop to the ceiling? Obviously, it's going to drop to the ground, and I could do that a million times, and it is going to drop to the ground a million times. It is never once going to drop to the ceiling without any force pushing it up toward the ceiling. Like, I'm not throwing it toward the ceiling, I'm just letting my hands go. It is always going to drop down to the earth. This is because the Earth's mass is much bigger than anything else on Earth. Obviously, Earth is the largest thing that is near us. So, with every single bit of mass, even you guys, you all have a gravitational pull. Everything that has mass has a gravitational pull. So you have a gravitational pull, your dog has a gravitational pull, cars have gravitational pulls, and we are all pulling on each other, technically. But since we're so small in the grand scheme of things, we don't feel that gravity. We only feel Earth's gravity. Now, the sun is much bigger than the Earth, so it obviously has a bigger gravitational pull. That's why the Earth is stuck in orbit around the sun, because of its gravitational pull. However, we're not being pulled toward the sun isn't swallowing us up, because we're too far away from it. If we got closer to it, then yeah, we would be pulled into its gravity and we would enter the sun and perish. But that is not happening, and that will never happen. So gravity is the force that is pulling us down toward the center of the Earth, Earth's core. My cat is screaming. Sorry about that. Okay, I will proceed. So air resistance is what you guys are going to be doing today, what your lab is going to be on. So air resistance is a force that opposes or pushes against a falling object. So let's talk about that book again. You drop the book and it, falls like it would because of gravity. But there is a little bit of air resistance that is pushing up on that book. So air resistance pushes up or against in the opposite direction of the way that the object is falling. So the larger the surface area of an object, the greater the air resistance. So if you're dropping a book and you're dropping, let's say, a battery, okay, a battery is much smaller than a book and it has a smaller surface area. It doesn't have like this big kind of uninterrupted vast space like a book does. It's compact, it's small, and it doesn't have a lot of surface area. So if you were to drop those two things, the battery would drop quicker because the air resistance isn't pushing as much up onto it. The book, on the other hand, it's being stopped a little bit by air resistance. And the video that you're going to watch is going to show that. But in physics, and it's really important that you guys know this, in physics, they often talk about the absence of things. So, like, for example, the absence of air resistance or other things. I can't think of anything right now. The absence of air resistance. absence meaning let's forget it exists, okay? With the absence of air resistance, all objects will fall at the same acceleration. So, air resistance is created by our atmosphere, oxygen, nitrogen, carbon dioxide, vapors, everything that makes up our air. That is what creates air resistance. If you suck all the air out of a location, an area, there will be no air. Therefore, there will be no air resistance. There will be nothing stopping the dropping of something. There will be nothing working against the force of gravity. So this number right here, 9.8 meters per second squared, that is the acceleration that all things drop at without air. So let's say you suck the air out of a room and you drop a bowling ball, you drop a brick, you drop a battery, you drop a book, you drop a feather, you drop a shirt, all from the same height, they're all going to fall at the same rate because surface area really doesn't matter anymore. If there's no air pushing against the object, making it fall slower, they will all fall at this rate. Now, this is what we call the gravity constant. Gravity constant. Constant meaning it doesn't change. So this is the acceleration or the rate of gravity. 9.8 might be a little bit difficult for you guys to remember, so you could round it off to 10 meters per second squared. It's much easier to multiply and divide by 10 as well. You don't want things to get messy with the 9.8. So just figure that 9.8 equals 10 and the gravity constant is 10. Now you need to remember 10 because you are going to be using it in some math problems, probably the next time we quote unquote meet, which will be next week at some point. Okay, here is the video that you're going to watch. I'm not going to play it now, but I will post it. You must watch this video. It's actually really cool. And this is our last slide. Terminal velocity. Now, do you guys know what terminal means? Terminal means to stop or to end, okay? And velocity just means moving. So, as an object falls, the force of air resistance becomes greater and greater and greater until it cancels out gravity. So, it doesn't increase exponentially forever. It increases, but then it stops. So once the acceleration due to gravity cancels out, the object reaches its terminal velocity, or quote unquote stop, and cannot fall any faster. So have you guys ever heard of that story that if you drop a penny off the Empire State Building, it will kill someone? Well, that is not true. If you drop a penny off of the Empire State Building, sure, it will start out slow as it's dropping, and then it'll pick up speed, pick up speed, pick up speed. But at a point, it will stop. It won't stop falling, but it will stop picking up speed. It will not gain any more acceleration, and it will just fall at the same speed the entire way down. So it might hurt somebody, like dropping a penny from the Empire State Building. It might feel not so good. You might get a bump on your head, but it will not kill you because it cancels out gravity. It essentially stops gaining speed, and it stops gaining speed actually pretty quickly, like only a few meters it stops gaining speed. So with that being said, I am going to post a few videos. I want you to watch them, and then you are going to do your lab. And that lab will be completed within the lab report. Sorry guys, I'm watching my cat play and he's distracting me. So yeah, let me know if you have any questions about this. Please watch the videos, and I will actually probably post a video of myself doing the lab so you guys can see exactly what's going on and exactly how to do it. All right? Have a good one.